this is just to show you the effect of the path difference. And here the path difference at P, as a result of the path difference, that the waves meet in phase. So I got a larger amplitude of the resultant wave. Here at R, the waves meet anti-phase, crest with the trough. So I got the resultant amplitude 0, so it will be a darker region. How can we determine this? No need to draw waves as what I did now. What I have to do just to find the path difference, guys. What I have to do just to find what? The path difference, like the following. To know if it's in phase or anti-phase, you have to measure the actual path difference divided by lambda. This, guys, will give us what? The path difference, but in terms of what? In terms of lambda. In terms of lambda. And if I divide the actual path difference divided by lambda, I will get the path difference in terms of lambda. Here we have 2 or 3 possible things. If the result is integer, this is n phase, right? If the result is odd over 2, odd integer over 2, this is antiphase. Here, guys, otherwise هذا بيكون out of phase. Otherwise هون ايش راح يكون ايش؟ out of phase. No need to draw waves. You can determine this, guys. You can determine this using ايش? You have to find the actual path difference, then divide the actual path difference by lambda, so you will get the path difference in terms of lambda. Then if the result is integer, so they meet in phase. If the result odd integer over 2, this means that they meet out of antiphase, otherwise out of phase. In phase, guys, again, pay attention here. In phase, this means that they meet, just a moment, guys, I will answer your question. They meet crest with a crest or trough with a trough, so I got a brighter region. Antiphase, this means that they meet crest with a trough, so I will get a reduction of the amplitude, or 0, or reduced amplitude, sorry, or 0. This means that I will get a dark region. According to this, we have to define something called interference. The interference, guys, it's a phenomenon in which waves overlap. As a result of this overlapping, they will superpose to form resultant wave. This resultant wave has greater or lower what? Amplitude, as what we see now. Look here, guys, to this. Here we have 2 waves, if you see them. They are moving towards each other. At certain moment, they start overlapping, right? They start what? Overlapping. As a result of this overlapping, we will get a resultant wave, like according to the superposition principle. Here, totally overlapping. After a while, guys, what will happen? These waves will continue in their position, in their motion, sorry. They will continue in their motion. This is the concept of interference, which is a property of waves. Property of waves means that, guys, or interference means that, and when the waves meet at certain point, their directions will not change. Their directions will not change. After the moment where they meet, they will continue in their directions. They will continue in their directions. Nothing will happen except at the moment, just at the moment where they meet. It's unlike the particles, because guys, particles, when they interfere, when they collide, let's say, their directions will change. Their directions will change, definitely. Okay? After that, guys, each one will continue in its position. احنا for simplicity, we will talk about only the waves, or the waves that they are moving in opposite direction. هلا the point of interference, guys, انه في عنا two waves that they meet, overlap at certain point. Okay. As a result of that, their displacements are add up. Their displacements are add up. Okay. Hello, we have two types of interference. First of all, it's called constructive interference. The constructive interference, guys, is taking place when the two waves meet in phase, يعني crest with the crest. Right? This is in phase. Crest with crest. The result of that, I got what? As a result of superposition principle, I got one wave. طبعا at the moment of interference, guys, pay attention. This is at the moment of interference. After a while, each wave will continue in its position. They meet in phase, يعني crest with the crest. The superposition principle give us that resultant amplitude is 2a. The condition for constructive interference إنه the path difference should be n lambda. 1 lambda, 2 lambda, 3 lambda. Okay, like what did we see before? After a while, they continue in their positions. The other type of interference, it's called distractive. Distractive, guys, the two waves meet antiphase. Look here. Crest with a trough. At the moment of overlapping, their displacement ايش بتصير؟ Zero, resultant displacement. Right, the resultant displacement is zero. To have destructive interference, guys, the path difference طبعا in terms of lambda should be odd integer over 2, or they write this like n plus half lambda. Guys, because you have to write this in our explanation, and later on I will show you, and we have to write why there's a destructive interference here. You have to mention that the path difference is n plus half lambda. N plus half lambda. Okay, guys. Then we defined the interference. حكينا when the two waves. We defined the path difference. We defined the superposition principle. يعني the path difference with superposition principle are important concepts for interference. This is what I explained here, guys. This is an interference, basically. Here, this is an interference. Here, we have interference of waves at P. Here, we have interference points at R. At P, I got what? A trough with a trough. So the resultant amplitude is, or they meet in phase. At P, they meet in phase. As a result of that, they meet a trough with the trough. So I got a larger amplitude resultant wave. If they meet antiphase like R, I got a trough with a crest. So I got a zero amplitude or reduced amplitude. So I got a darker region. Now, the first interference that should be taken per consideration, it's the interference of light. Interference of light, which is called, the most common example about the interference of light, it's called Young's slit experiment. Young double slit experiment. I will show you this experiment now on the YouTube.
Through the mist, I saw a figure emerge, and with it, a darkness advanced.
And this experiment uses two slits, as the name suggests. And this is really an amazing experiment, and you've got to do it yourself to really appreciate it. But I want to take you through it with this video first.
Right here, this is, if you look to this red, yellow one, this is a laser source. This laser source placed on a brick. It should be, guys, horizontal. I will show you why. It should be horizontal, or the source should be horizontal. Here, the one that you see here, it's called double slit, right? Double slit. Here I will have double slit, so the light incident on this double slit. I will show you what will happen now.
If you're in my class, then you're going to do it next lesson yourself. We've got enough for you to do this experiment in pairs. So what does it involve? It involves this, which is a spirit level that's got a laser in it. So if I point that at the wall there, hopefully you can see it's a red laser. It's a nice low power laser that's going to be safe for us to use. Young did this hundreds of years ago, so he didn't have lasers, but they make our life easier, as you will see. We've got this thing here, which is a collection of double slits. So if you look really closely, you can probably see 4 slits in this slide. If I hold it up to maybe a white background, you see it more clearly. Each of those things that you can see there, oh no, that's lovely, that's focused really nicely. So you can see that each of those things that look like...
Okay, guys, here this is called double slit. Here we have several double slits in this sheet. Okay, they are separated at different, or these slits are separated at different sides. Here they are very close. Here, look to the separation between the slits. Okay. The thickness of each slit is 0.15 millimeter. The thickness of each slit, right, guys? The thickness of each slit is 0.15. This is the separation between the slits. The first one, 0.25. The second one, 0.50. Third one, 0.75. Last one, 1 millimeter. Okay. Now look to the what will happen to the laser light.
One slit is actually a pair of slits, and the ones on the right are quite far apart, and the ones on the left are really close together. So these are double slits. What happens when the light passes through these two slits is that it spreads out. So when light passes through a narrow gap, it spreads out, it diffracts.
Is that
and then the light...
When the light is incident on these slits, at each slit, guys, pay attention to this. At each slit, the light diffract or spread out in all directions. Okay?
light coming from each of those two slits can interfere. So I'm going to shine the laser light through. I'm going to use the leftmost pair of slits because that's going to work best. So I'm going to shine this laser through a double slit, and then all the way over there, I'm not sure if you can see it,
Guys,
is a screen.
if you
It's
look
a long
here,
way.
the screen is far away from the source, right? This is a precaution. If I want to observe, later on we would call it an interference pattern. If I want to observe a clear interference pattern, the screen should be away from the source at least 1 meter. At least 1 meter.
Away. And you'll find out why that is shortly. So here we go. I'm going to turn the lights off. I'm going to turn the laser on, and I'm going to direct the laser through two of the slits. So the laser light is going through a double slit, two slits very close to each other. All the way down there on the screen you might just see some red. Now, actually, let me show you what it looks like without the double slit. Without the double slit, it looks like a dot.
Guys, this is without double slit. Yani if the laser is shown directly on the screen, right? If there is no slit, if there is, I will see like this.
Okay, let's go back. Now, I've put a double slit in the way. So the laser light is passing through both of those slits, it's spreading out, it's diffracting. But when it gets over here, you get this very interesting pattern.
Okay, guys, look to what will happen here. Here, guys, I observed on the screen, instead of one single spot of light, I observed several spots of lights like this. طلع معي هون please. Guys, طلع معي هون.
Okay.
هلا without ال young double slit, without the slits, I will observe only one single spot at the center of the screen. Here, what do I observed here? Bright regions. وhere if you see this, طلعوا هون هاي المنطقة وهاي المنطقة. Let me use another color. Did you see this? Regions between the bright spots. Did you see them, guys? These are dark regions. Right? So bright regions and dark regions. What does this mean? Again, guys, best pay attention for this. The waves are diffracted from the slits. They propagate in all directions. They reach the screen. If the waves meet at the screen, if they meet in phase, يعني crest with a crest, or trough with a trough, I will get a bright regions. Okay? In certain places, I got a dark region since the waves are meet anti-phase. يعني crest with what? With a trough. The thing that we will observe, or the thing that we observed here, it's called interference pattern. This is what? Interference pattern. Okay, this is an interference pattern, guys. We observed this interference pattern. We observed bright regions, dark regions. The explanation for that, as what we mentioned before, here they meet in phase, here they meet what? Anti-phase. Which one is the brightest one? The central. صح? Did you see it? Central one is the brightest. I will explain why. Guys, هون احنا عندنا two slits, right? فعندنا كأنه two sources of light. بالcenter all of the waves from slit A و slit B meet at this point. All. فعشان هيك بيكون عندي several waves, or all the waves meet at this position, is central. as they meet فبيكون عندنا adding للامبليتيودز لهم كلهم. as a result of that I will get the brightest one. The second one اللي هي هاي شايفينها وهاي هون بيكون not all most of يعني خلينا نقول اقل مش كل الويفز they will reach here شوي طارق مش كل الويفز they will reach here some of او خلينا نقول most of them they reach here عشان يكون brightest اقل. As we move away from the central region بصير less waves reach these positions صح. فعشان هيك بتكون البرايتنس اقل او less than the central one.
بس بقدر اسال سؤال. البوينت اول واحده اللي كانت لحالها هاي كنترول بوينت.
We can consider it as control point بس هي بدون الديفراكشن بدون الباترن يعني ما في دبل سلت هي لحالها هيك يعني الليزر is shown directly على السكرين تمام. اوكي فانا ما عندي I don't have any diffraction فعشان هيك راح اشوف بس سبوت واحده. هي ليش بصير اشوف انا الانترفيرنس باترن لانه في عندنا spreading out للويفز as a result of this spreading out للويفز بقدر اشوف interference pattern في points معينه. طيب يس
نقدر نقارنهم بعض. اوكي
guys in the previous time we watched video about something called interference of light. In this video guys we had a source of light. It was a laser, double slit and screen. If I look guys to the screen what do I observe here طلعوا. Let's go back to this. Let's go back to this. Here I have bright regions, right? وdark regions, right? Bright regions وdark regions. As what we mentioned before, guys, the bright regions, the waves meet in phase. يعني at this point, all the waves meet in phase. At this point, all the waves meet in phase. In the dark regions, all the waves meet antiphase. Antiphase means the crest with the trough, for example. So we will have reduction in the amplitude. So we will have reduction in the intensity. Reduction what? In the intensity. As a result of that, I will observe a dark region. Here in the bright region, guys, they meet in phase. So they interfere constructively. So crest with the crest, so the amplitude increases, the intensity increases. Again, guys, why the central one, central high, is bright? Why is the central the brightest one? The brightest one, guys, because all of the waves from the two slits here, guys, the waves that or the light that reach these slits will diffract in all directions. Okay, will diffract in all directions like this. Okay, the waves from this slit and this slit diffract in all directions. They meet here, they meet here, they meet here, guys, from the two slits. The central one has the highest intensity because all the waves from the two slits will meet where? Here. So we will have the brightest fringe. The second one, not all of the waves reach this region, and so on here. Not all of the waves reach these regions, okay? So we will have a brighter region, but not as the central one. The dark region, guys, wait a moment, طارق. Dark region اتفقنا هدول they meet antiphase, so they interfere destructively. They interfere what? Destructively. They meet trough with the crest. Okay? يس طارق.
استاذ، طب كل الويفز دي بيعملوا ميتنج بالنص، هدول لازم يكون ان فيز عشان يطلع لون، صح؟ انه لو كان وحدات مش فيز ما بيطلعوا لون.
100%. Okay. So the laser light is directed towards two slits that are separated by a fraction of millimeter. The screen is placed away by typical value 1 meter. ايش الobservation؟ حكينا series of equally spaced bright dots are observed on the screen. A laser is used, guys, because it's coherent. Okay, a laser is used instead of the color of the light لأنه هذا ايش؟ coherent. Guys, in order to observe interference pattern, listen to me, this is an important point, guys. In order to observe interference patterns means what? Series of equally spaced bright dots, or this is interference pattern. This is what? Interference pattern. To observe this interference pattern, the light must be coherent, or the sources, or the light that is outgoing from the slits, the light that is outgoing from the slit should be coherent.
إذا ما كان coherent شو بصير؟
أيوة, we did not observe this pattern. يعني هلا in your homes, guys, if you look مثلا to the lights that are used in your homes, I will not see interference pattern, even that there is an interference between the light لأنه بيكون عندنا several lamps أو several sources of lights موجودين in our room, right, or exist in our room. But I did not observe interference pattern because, guys, these types of lamps are incoherent. What does this mean? They have random phase. They have random phase. يعني what is the result of that? يعني if I took a region مثلا هون, guys, if I took this region here, let's talk about this one. And as what I mentioned before, in this region, all the waves that reach at this moment, at this region, meet in phase. So we will have constructive interference. And if they have random phase, let's say, in this region, there are waves that are coming or reaching this point from different sources. They have random phase difference. If they have random phase difference, so I will not have a specific region where there is an in phase or a specific region where they meet anti-phase. يعني هون مثلا ممكن at first second, let's say, if I can say this, at first second they meet in phase. In the second they meet out of phase. In third second they meet anti-phase. Fourth second they meet out of phase. This is what is meant by random, right? And here let's say pi over 2, here pi over 4, here. هلا اذا انا بدي يكون عندي إشي coherent, طلع شو راح اعمل هلا متفقين انه sunlight شو هو n coherent. تعرفوا لو انه sun coherent كان مصيبه، كان بشوف regions dark و regions bright. هلا sun is incoherent، بس if I use a single slit، السنجل سلت خلت اللايت ايش يصير فيه هون؟ coherent. تمام؟ بعدين هلا صار coherent lights، هدول coherent lights او coherent light reaches double slit. As a result of that they will spread out. هلا قلنا ال interference here according or as a result of this double slit the waves diffract, so they meet at certain points. These points, regions dark, regions bright. هلا this is the explanation. A bright region, or it might be called fringes. Okay, guys, bright fringe or bright region. The explanation for that, the constructive interfere, the waves meet on each other in phase, the vector sum of their displacement add up, hence they produce what? Maxima. In the dark region, there's a destructive interference. The waves meet out of phase or anti-phase. The vector sum of their displacement cancel each other, hence produce what? Minima. Is the light from double slit coherent or incoherent? State the reason for your answer. The light from the laser and therefore the waves leaving the slits are coherent. اتفقنا. The phase difference is constant. أهم شيء إنه يكون phase difference constant, so the interference pattern can be observed. If the path difference, guys, if the path difference round lambda or integer of lambda between the waves that are outgoing from the two slits. So we will have a bright fringe. If the path difference between the two waves that are leaving the slits, as what we mentioned before, n plus half lambda, this will produce dark fringe or destructive interference. Here we have, guys, a formula or mathematical formula that represents the double slit interference or double slit interference pattern. I will observe, as what we mentioned before, bright, dark, bright. Here we will have dark region, then bright region, and so on. Okay. Like, guys, here we have to define three quantities: A, D, X. What is A? A, guys, it's the separation between the slits, or from the center of the first slit to the center of the second slit. D, it's the distance between the double slit and the screen. Or X, guys, it's the distance between two adjacent bright fringes or two adjacent dark fringes. Okay, distance between two adjacent bright fringes or two adjacent what? Dark fringes. This is the most important one. Adjacent fringes, okay, either dark with dark or bright with bright. Lambda is the wavelength. A is the separation between the slits. X, it's the separation between the fringes. D is the separation between the double slit and the screen. Guys, this is a very important thing. Please pay attention now. Here I will, we have to know the path difference, or there is a pattern for the path difference to each region. So, and when I say path difference, we have waves that are outgoing from S1 and S2, from slit 1 and slit 2. These waves, again, guys, they meet here, they meet here, they meet here, they meet here. When I talk about the path difference, I have to take the path difference between S1 to this point and S2 to this point. This is the path difference that what I meant. Or if I consider the second region, then هذا الpath difference. هلا here at this point في عنا path difference S1 like this, وفي عنا path difference from S2 to this point. هذا اللي راح نحكي عنه ايش؟ path difference. Okay. If I consider this point, this is the path difference between this point, S2 لهاي البوينت و S1 لهاي البوينت. Is that clear, guys? Okay. Guys, the central one, the path difference from all the waves that are going from S1 to S2 is 0 path difference. ناخذ البرايت أول شيء. هون الباث difference، خلينا أعمل هيك. السنترال بيكون 0 الباث ديفرنس. الفيرست اوردر بيكون لامدا الباث ديفرنس، السكند اوردر بيكون 2 لامدا، الثيرد اوردر بيكون 3 لامدا. similar here. الفيرست اوردر لامدا، second order 2 lambda, third order ايش 3 lambda and so on. So the path difference always increased by lambda for each bright fringe. For each bright fringe, the path difference increased by 1 lambda. For dark fringes, guys, for dark fringes, first one lambda over 2, second one 3 lambda over 2, third one 5 lambda over 2 or 5 over 2 lambda and so on, 7 over 2 lambda. This way, guys, because as you know that to have a dark region or dark fringe, the path difference should be odd integer over 2. Odd integer over 2. Here similar thing, رح يكون lambda over 2. Here 3 lambda over 2. Here ايش 5 lambda over 2 and so on, 7 lambda over 2. So there is a pattern for the path difference. For bright we have a pattern, and for dark we have another pattern. يعني let me read this, guys. This is a very important thing. هلا خلينا نرجع لهذا البارت. ركزوا معي. A السنترال صح، B الدارك، و C ايش البرايت and so on. هلا if I consider A, both waves have the same distance, right? It travels to the center of the screen, so their displacement add up, they are coherent, so the bright fringe is formed. The path difference شو بيكون 0. At B قد ايه path difference اتفقنا بيكون half lambda. شو يعني path difference half lambda؟ تفرجوا معي بالله. طلع معي عند B. Guys, light that is travel from 1 to B has larger path than the light that is travels from 2 to B. It's very clear إنه هذا length more than this length. طب قد ايه الديفرنس بين هذا الباث وهذا الباث؟ لأنه الفيرست دارك ريجن الباث difference half lambda. In other words, guys, اسمعوني شوي. The light that is outgoing from slit 1 moves half lambda extra، أو خلينا نحكي زيادة على الباث وبين مين؟ بين 2 و B. عند C طالما عند C هاي C عندنا waves are outgoing from 1 هايها، waves outgoing from what? From 2. Since C هي ال first bright fringes معناته phase difference بيكون lambda path difference. شو يعني هذا الشيء؟ يعني light that is going from 1 travels extra 1 lambda or greater than by 1 lambda light that is travels from slit 2 to C and so on. طبعا هذا هو الكونسبت تبع path difference. عشان هيك path difference جماعة affects interference. Path difference affects what? The interference. Here, guys, if I use, this is monochromatic. Anyone remember what is monochromatic? Chromatic?
انه عنده one wavelength.
Exactly, single wavelength. Monochromatic light, guys, بيكون عنده single wavelength. If I did not use monochromatic, if I used white light, sorry, source. This is if I use monochromatic source. Look here, guys, what we will see. Later on we'll explain that. here central is bright. الفيرست order spectrum, second order spectrum as well. صح؟ طبعا هون في منطقة دارك ريجن بس مو مبينة. بعدين هون برضو عندنا ايش؟ spectrum and so on. طيب how can we explain this؟ هلا first of all guys I have to know that إنه ال path difference depends on the wavelength. صح؟ هلا بالسنترال قد ايه الباث ديفرنس؟ قد ايه الباث ديفرنس بالسنترال؟ قد ايه الباث ديفرنس بالسنترال؟ جماعة الباث ديفرنس بالسنتر زيرو. طيب هون قد ايه الباث ديفرنس لازم يكون؟ 1 لامدا صح؟ الفيرست اوردر راح يكون 1 لامدا. Red has different wavelength than مين؟ البلو صح؟ فلاحظوا انه الباث difference listen to me guys the path difference where the red interfere constructively is different than the path difference where the blue interfere constructively. فعشان هيك عند هذا البوزيشن مثلا ركزوا بالله شوي عند الريد شايفين هذا الريد at this position guys all the colors interfere destructively يعني كلهم عندهم anti phase they meet here anti phase except mean أو out of phase sorry except mean الريد interfere here mean constructively. فعشان هيك بهاي الريجن ايش ببين معي؟ ببين معي بس الريد all other colors are not appeared at this position. بهاي الريجن راح يبين معي only red color because all other waves or all other wavelengths interfere destructively فما راح اشوفهم. بهاي الريجن all the waves interfere destructively except mean except the green. May write like this انه each each wavelength has a certain path difference where they meet in phase أو interfere constructively. I will the center if the path difference guys is zero يعني إذا path difference is zero معناته it's independent of lambda صح ولا لا؟ وما في path difference أصلا. If it's independent of lambda all the waves هون بالcentral region هون all the waves meet in phase. ما في path difference مو path difference zero. فكل الwaves meet in phase. if I mix all the colors together what do I get? The white one. Okay?
White.
Any question about that? هلا in the previous time guys حكينا عن إشي اسمه path difference صح؟ Okay guys طلع معي مرة تانية I will re-explain this. هلا here we have waves meet at point A from slit A slit 1 و slit 2. Guys look to the line that I will draw now or pay attention to this. This is the path from slit 1 يعني S1A و this is the path from ash slit to A. The path difference S1A minus 2A. If I consider S1A with S2A, يعني هذا الباث مع هذا الباث. If I subtract these paths, I will get 0 path difference. Okay, at A. This is when? At A. At B, this is at B. This is the path of the first ray, or the first light travels. This is the second path. Okay. This one is S1B, or this one is S2B. Okay, guys. Hela, we have to understand this point. You know, as what you mentioned before, we have bright, dark, and so on. Hela, we have to understand. We have to link this with the path difference. We have to link this with path difference. This is what path difference. Guys, at A, path difference من slit 1 to A. I will use red. It's already red. I will use green one. Guys, pay attention now to the line that I will draw. This is the path of what? S1A. And this is the path of the light that is outgoing from slit 1 to point A. Well, this is the path of the light that is outgoing of slit 2 to A. Okay? They interfere. If I measure this path difference and this path difference, I will find that they are the same. يعني the path difference between them is 0. If I consider point B, if I consider point what? طلع معي point B, guys. At point B, we have waves that outgoing from slit 1 to B. This is the first path. We have outgoing waves from slit 2 to point B. This is the path S1B, or this is the path S2B. If I measure this path difference, I will find it, if I compare it to lambda, I will find it's half lambda. Yani if I compare the path difference with the wavelength, I will find it lambda. So a dark region, the path difference بيكون عندها integer of half lambda. The first bright region, as what I explained here, on. The first bright region, the path difference شو بيكون? Lambda from S1 to S2. The second bright region, the path difference between S1 and S2 at this point is 2 lambda. For the third region, bright region, the path difference from S1 to S2 at this point is 3 lambda and so on. The path difference عند الدارك region, أول dark region بيكون half lambda, بعدين بصير 3 over 2, بعدين 5 over 2, and so on. Let's continue. هلا I explained that for you in the previous time, guys. Now here I had what? If I have white source. If I have what? White source. In the white source, guys, I will, instead of, look to this, instead of bright regions and dark region, the bright region will be spectrum. This is the bright region. Okay, this is what? The bright region. And the bright region here will be a spectrum. So here I got a spectrum. The bright region here also a spectrum. And so on. Why do we observe a spectrum? Not a single wave. Here, let's roughly speaking, right? Let's say that إنه الwavelength هيك roughly speaking طبعا this is wrong. The wavelength for the red is 3 centimeters, with wavelength for the blue is 1.5 centimeter. This is totally wrong, you know this, but I want to show you something. This is a screen. Here I have to draw what? 2 slits. Slit 1, slit 2. وهي source of light, laser, whatever. Okay, guys. Now, this is, I think, the central point.
Okay.
If I took this point as a central point, صح؟ فإن أنا عندي هون هذا السنترال، صح؟ Okay. Okay, guys. طيب. We will talk about this later. Here, guys, let's take these two positions. Here حكينا هاي السكرين. هن عندنا central one وهير the first one. هلا let's say إنه central one الباث difference قد إيه؟ طيب. If I consider here إنه الباث difference هون is 1.5 سنتيمتر عند هاي البوينت، مثلا هاي البوينت A. Okay, guys. هلا if I want to check what will happen to the center for red أو at the center, for red قد ايه path difference عشان to know or to judge if it's constructive or destructive, I have to divide the path difference over lambda, right? The path difference 0, lambda what? 3, so this is 0. Is that integer, guys? So here we have what? Constructive interference for red. For blue, we are still talking about what? Center. For blue, again, guys, the path difference over lambda. The path difference 0, lambda 1.5, which is 0, which is also integer. So here we blue light also make constructive interference, right? Constructive what? Interference. Is that clear? So guys, at the central point, what do I observe? I will observe both of them. The blue والred, right? يعني عند السنتر راح اشوف blue و red. طب if I divide 0 by any wavelength, so eventually I will get integer. So as a result of that, at the center, all the wavelengths will interfere constructively عند السنتر. فراح اشوف white light، ما راح اشوف any other color. هلا لو اخذنا at point A، at A, this point, okay? For red, path difference over lambda. الباث difference 1.5 over lambda ل 3. فهذا ايش راح يعطيني؟ half. What does this mean, guys? This is a destructive interference. Let's check for blue. Path difference over wavelength. Path difference 1.5 over 1.5. This is what? 1. This is integer. So here we have what? Constructive interference. On odd integer over 2. طيب, what does this mean, guys? إنه عند هاي البوينت, عند point A, pay attention. At point A, الred interfere destructively, والblue interfere what? Constructively. As a result of that, what we will observe? We will observe red. We will not observe the red لأنه destructive interference, but we will observe the blue. The thing that I want to show you here, guys, إنه constructive interference with destructive interference will depend on what? Will depend on the path difference. Well, path difference depends on the wavelength. يعني the same path difference طلعوا at A, the waves that are outgoing from slit 1 to slit 2 have the same path, so the path difference at A is the same for all wavelengths, for all colors. But as a result of change in the path, in the wavelength, we will have wavelength that, or wavelength of the waves that they constructively interfere, wavelengths for the waves that destructively interfere. This is what I explained in the previous time, guys. إنه central راح يكون الpath difference 0. If the path difference 0 and I will observe all the colors at this position, if they mix together I will get the white light. لو أخذنا any of these positions like what I did in the previous time, if I took this one, this region, guys, path difference, path difference of the red is integer, while other colors are not integer, so they are out of phase. Red is in phase, so the red is constructively interfere, so the amplitude of the red light will be higher, so the intensity higher, so it's dominant, so I will observe the red only. يعني بهذا البوزيشن, in this position, هاي هاد هلا in this position ايش مبين؟
وعند اليالو مثلا بيكونوا
بس ايوه
بس يالو,
like what I show you here. هلا عند هاي البوينت A, عند هذا البوزيشن بالضبط, if I consider these numbers as the right numbers, تمام, and I will observe red, I will observe the blue, راح اشوف البلو بس ما راح اشوف الريد, صح؟ لانه الريد عند هاي البوينت بيعمل destructive interference بس البلو بيعمل constructive. Is that clear? Any question, guys?
The box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light. When the light from one slit met up, peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
This is basically the same.
Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave...
Okay, guys. Here, guys, in this video, we observed that we have, let's say, two sources of water waves, like what do we observe here? They must be coherent. They must be what? Coherent. Guys, here, if you look to this, to the line that I will draw here. Look to this line. Look to the line here also. Guys, in these regions, right? In these regions, we have destructive interference. Right? As what he said, you know, in this region, guys, crest and trough meet. فإف you observe here, guys, no disturbance. طلعوا كأنه ما في disturbance. يعني كأنه there is no wave here. There is no disturbance at this position. Or along this line, there is no disturbance. Because the two amplitudes, guys, or the two displacements are cancelled out since they are a crest with a trough. In this region, guys, this region had a constructive interference. So which means there's a magnifying amplitude, right? Or the amplitude is magnified. Their displacements are add up, right? So here we have a constructive interference. Any question about that, guys? Here, if I consider this, right? Like the video that we watched now. Here, guys, this is, or along this line, we have destructive interference. Along this line, we will have a destructive interference as well. Along this line, we will have a destructive interference and so on, guys. Between them, this region, guys, destructive. Guys, to observe this pattern again, this region what? Constructive and so on. Guys, to observe this pattern again, the two sources that they produce these waves must be coherent. Okay. You might be asked to draw a region where, or two lines to represent constructive and destructive interference. To make it, or to draw a constructive interference, guys, constructive. طبعا, before explaining this, when you draw like this line, guys, this line and this line, the space here. I have to explain what is meant by that. Guys, just to remind you. This line may show you the crest. Okay, يعني the solid line, guys, here, the solid line are representing the crests that are moving together. اللي هي الwave front, right? The space between these lines هذا السبيس هذا التروugh. This is what do we observe, guys. The crests are observed to be lines with space between them as observed as the trough. This is a crest and so on. Okay, any question about that? So in order to find the region where constructive interference takes place, طلعوا على intersection of crests. Right? The intersection of what? Of crests. So in this is the point where there's constructive interference. طلعوا هدول points. برضو هون عندنا constructive where the crests meet. Look to these points. Sorry. and I meant at these points, right? Okay, guys. You will be asked to do this, guys. You will be asked to draw a line to show where is the point of constructive and the point of what? Destructive. I may consider also this point, just to show you something. This is also what? Constructive interference, guys. Constructive what? Interference. Now, the region between between two constructives or two constructive interference رح يكون destructive. Guys, pay attention to this point. Pay attention, please, guys, all of you. At this point, guys, there's an interference between crest. شايفين الكريست مع التراف السبيس. احنا اتفقنا هذا السبيس هو تراف. صح؟ هذا السبيس اللي هون شايفين هذا السبيس هو التراف. This solid line is the crest. So if crest and trough meet, this means that we have destructive interference. Here again, guys. This line, crest, with a space between هذا space, trough. So in this region, guys, I can draw here a line, red line, between the two constructive interference. In this line, guys, we have a destructive interference. We have what? A destructive interference. I may consider another line here. This point, crest with a trough. 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 So the space, guys, between the solid lines, these spaces between the solid lines will represent the troughs. With solid lines will represent what? The crest. This is a destructive what? Interference. How can I demonstrate the interference of water waves? I have to use what? The ripple tanks. I have to use what? The ripple tanks. Here I have to use, instead of one dipper, I will use two dippers. Like what he did in the video. But he used his hands. But here we may use a generator. هذا اللي هو ايش؟ wave generator. Here two dippers, right? They will produce circular waves. These circular waves, guys, they will meet or interfere. So I will get an interference pattern as what we see in the video. The main point, guys, or the main important point that you might be asked about it, these dippers must be coherent and should be connected to the same source or same vibrator bar, bar, in order to have two coherent sources. اللي هم اللي حكينا الانترفيرنس pattern. يعني احنا ايش يعني interference pattern؟ انه in specific region always we have constructive interference. In specific region we will have a destructive interference. فأنا I will observe bright dark, or I will observe a region where the amplitude is larger, or the region where there is no disturbance زي ما شفنا هلا بالwater waves. في region there or these regions, guys, no any disturbance because crest and the trough meet, so and they cancel each other. فما في disturbance, ما في amplitude. Okay. I'll explain the term interference. حكينا interference when two waves meet or overlap. They superpose. فهذا هو الكونسبت تبع الانترفيرنس. Ripple tank is used to demonstrate interference between two water waves. Describe apparatus used to produce two sources of coherent waves that have circular wavefronts. It's already here. هاي الانسر هون. Right? We will use circular dippers or sphere dippers. They are connected to the same generator in order to make it coherently. I have to draw this. I have to draw what? This. How pattern of interference waves may be observed. حكينا السكرين وين بدها تكون. السكرين بدها تكون behind the water tank. as a result of that we will use stroboscope أو camera to freeze the waves. هلا we are given like this. Here what we are asked to find, draw two lines to show where maxima would be seen. اتفقنا هون ايش نعمل؟ بجيب الرولر بشوف ال points of intersection تاعت ال waves like this. صح؟ وهاي ال points of intersection. these points of intersection. These guys حكينا هاي points of intersection of the two waves will be ايش؟ will be constructive interference أو maxima. We are asked to label it as X. Sorry, label it as X. هلا between them, between two successive ايش؟ maxima بيكون في عندنا minimum. Between two successive maxima راح يكون عندنا ايش؟ minima. Right here, in this position, we have what? Minima. Here we have what? Minima. Okay, which is labeled by n, which is must be labeled by n. Between any two successive maxima, there is a minimum. Okay, guys, any question about that? Type. Next time, inshallah, we will complete this topic by solving the past paper questions that are related to this topic. وإن شاء الله يعني by the end of next week بنخلص ال partial waves hopefully إن شاء الله. Okay, any question?